Welcome to Algebra 2, Lesson 2-7, Quadratic Functions and Linear Functions. Example 2, solve a linear quadratic system using substitution. How can you use substitution to solve this system? Y equals 3x squared plus 3x minus 5 and 2x minus y equals 3. So using algebra, we're going to solve this together. In order to figure out your solution, your intersection point, right? We want to find the values where they have the same values, right? So we're assuming that these y's are going to be the same and these x values are going to be the same. So we can set them equal to each other. That means when we solve for y, right, in terms of x, your second equation becomes y equals 2x minus 3, right? And so you're going to substitute this into your second equation and solve for your x as well, where 2x minus 3 is equal to 3x squared plus 3x minus 5. Or you can just substitute this, which is already solved for y, into your second equation here. And that's what the textbook showed you. But either way, it's fine. Since it's already solved for y, it just seems easier to substitute your y of your first equation into your second equation. So once you substitute, then your y is gone because you substituted your equation in terms of x in exchange with the variable y. And now you only have the variable x. And so solving for your quadratic equation, you can factor it out and simplify and solve for your x values. You will see that x will have two solutions here, two real solutions, -1 and 2/3. And if you want to figure out the points, you need the y values as well, right? So you can either choose the first one or the second equation to plug in your values of x so that you can solve for y. And you'll see that both equations will have the same points when x is equal to -1 and y equals to -5, and x is equal to 2/3 and y is equal to -5/3. Okay, so this is how you solve by substitution. Let's try number 2. Solve each system by substitution. So solve part A and B and pause the video, see if you can do it by yourself. Come back when you're ready for answers. Okay, are you ready? Okay, let's look at the first equation. You're going to solve this by substitution. So since you have the first equation solved for y already, you can substitute this into your second equation and say 2x minus parentheses 2x squared minus 6x minus 8 would equal to 16. And then you can distribute your negatives. And then you can make it equal to 0 by subtracting 16 on both sides. And you'll get -8. And then you can add the like terms and get 8x is equal to 0. And then you can factor out your greatest common factor. And you'll get -2 times x squared minus 4x and then plus 4 is equal to 0. And then you'll see that this is going to be exactly x minus 2 squared, right? So your x is just going to be 2. So you only have one solution in this case. And your solution should just be 2, comma. You need to substitute it in. Use the second equation because it's easier to calculate your linear function rather than your quadratic. So 2 times 2 minus y is equal to 16. So your y is negative 12, right? And so that's your only solution, only real solution in this case. Let's look at part B. You do the same thing. You substitute your first, you can substitute the first equation quadratic into your second equation and solve by factoring your quadratics and solve for x. And in the same way, you will get your x values. In this case, you will get two different things, okay? So your two real solutions should be negative 2, negative 10, and 1 comma negative 2. Okay, that was solving a linear quadratic system using substitution in example 2. We'll continue with example 3, the application problem, in the next video.